In this lesson, we're looking at systems of inequalities, and really a system of inequalities is just two linear inequalities that we're going to graph at the same time. And when we do this, we essentially only graph the overlap of the linear inequalities. All right, and remember, when we're doing linear inequalities, we graph the linear component either with a solid or a dotted line, and then we shade one side of the line or the other. And so when we talk about the overlap, well, we've got two of these things, and we're looking for the shaded region that they have in common, all right, where their two shaded pieces overlap. All right, so here's what we're going to do. The easiest way to do this, instead of graphing both pieces and then seeing where they overlap and then erasing pieces, we're just going to graph the linear components. We're going to start with that, and then we're going to use test points to find the region that we need to shade. We'll test a couple points until we find one that works. Okay? For example, when I take a look at this first one, basically I'm gonna look at each of these individually. I'm going to think about the linear components to each of these. The first one has a linear component that's y equals a 2x plus 2, and the second piece has a linear component that basically says y equals a negative 1/2 x minus 1, and I'm going to graph each of those. So the first one has a y-intercept of 2 and a slope of 2, and then I remind myself that this thing is an inequality, so I have to decide whether I'm going to use a solid line or a dotted line, and since there's an equal to condition with this one, I'm going to use a solid line, so I'm going to use a solid line for this one. That is terrible. Let me try one more time. That's not much better. And then I nailed it. Okay. So I use a solid line for that one because there's an equal to condition. So then I graph the next piece of this thing. I've got a y-intercept of negative 1, and I've got a slope of negative 1/2. That's down 1 over 2. Or up 1 back 2. And for this one, because there's no equal to condition this time, so notice I just have the less than symbol, so there's no equal to condition, so I'm going to use a dotted line. And now basically what's happened here is I've basically split the graph. Instead of splitting it into two pieces where I have to shade one piece, I've split this thing into 4 pieces, and I'm going to have to shade one of these. All right? So now the first thing we want to do is we want to narrow this down. I basically want to try a point that I think is going to work. All right? I don't want to try a bunch of points that aren't going to work and keep guessing at this thing. So I look at each of these, and I notice that the first one says y is greater than or equal to that line. So I look at this line, which is my solid line. And if I want to be greater than that line, it means I want to be above the line, which kind of narrows it down to sections 1 and 4 here when I'm above that solid line, okay? So it kind of narrows it down to those pieces. When I would graph this thing, I would end up shading one of these two pieces if I was just graphing that first line. Well, the second line, the second piece of this thing, it says I want it to be less than that line, so I'm talking about this dotted line this time. And since I want to be less than that line, it means I want to be below the line, so it narrowed down to these two sections. So as we really start to think about this thing, if I get rid of all these marks that I had, the first line narrows it down to sections 1 and 4, and the second line narrows it down to sections 3 and 4. So really the overlap, I can kind of see where this thing would end up being shaded. It's going to be section 4. And really we could do this without testing a point, but we'll test a point just to be sure. And I would always choose a point that's on one of the axes, so I would choose like a point right here. So I'm going to test the point, looks like negative 4, 0. And I'm just going to plug this in, so I'm going to plug it into the first equation here, or the first inequality. So I plug the 0 in for y, and I plug the negative 4 in for x. And I just simplify, I get 0 is greater than or equal to, it's going to be a negative 6, which is a true statement, so I'm going to go ahead and plug it into the next one. So I've got 0 is less than a negative 1/2 times a negative 4 minus 1. So that's going to give me a 2 minus 1, which is 1. So when I do that, I get 0 is less than 1, which is also a true statement. So when I plug that ordered pair, and it works for both inequalities, which means it's a solution to my system of inequalities, which means that is the correct section, and I'm going to go ahead and shade it in. Okay? So really I'm just testing a point just like I did before, except it takes a little bit longer to narrow down which section it's going to be. If you understand how these work, we can make it a little bit easier by taking an educated guess as to which section. Okay? If I look at the next one, again I'm going to start with the linear components of this thing. The first one has a y-intercept of 1. and a slope of 3/2, so I go up 3 over 2. Since there's no equal to condition, it means I'm going to use a dotted line for this one. So I'm going to draw my dotted line. And then the next piece of this thing, I've got a y-intercept of -3 and a slope of -1/2. And this one, -1/2, let me try that again. And this one has an equal to condition, so I know I'm going to use a solid line this time. And now I just have to figure out which section I'm going to be shading. Well, since I want to be less than this first line, the first line was the dotted line, less than that first line narrows it down to these two sections. I want to be less than the second line, which means below the line, which narrows it down to these two sections, which means it looks like I'm going to be shading section 3. Okay, so what I do is I choose a point from section 3. I'm going to use this one. That's the ordered pair 0, -4. And I'm going to plug that in. When I plug it into this first one, I get -4 is less than 1, which is a true statement. And then I plug it into the next one. I get -4 is less than or equal to a -3, which is also a true statement. So now I'm absolutely 100% sure that that's the section I'm going to be shading. Okay? So I get my crayons out, and I do a little coloring. And there it is. Okay? If I look at the next one, again, I'm going to graph each of these, so I'm thinking about the linear components of each of these things. The first one has a y-intercept of 3 and a slope of 2. And there's an equal to condition with this one, which means I'm going to use a solid line. So I do a solid line for this one. And then the next piece has a y-intercept of -4 and a slope of 2. And this one has this one also has an equal to condition, so I'm going to use a solid line again. And now this only breaks it into 3 sections, 1, 2, 3. But there's actually a fourth option over here. The fourth option would be no solution. Okay? So really I need to choose between these 4 things, and the only way to determine that it's going to be no solution is if I can prove that the other 3 sections don't work. So again, I start to think about this thing in terms of narrowing it down. If I want to be less than this first line, well, here's the first line, was this one right here. Less than that, would it be everything below it would be sections 2 and 3. And then I want to be less than the second line. Well, here's the second line. Less than that line is just section 3. So we can see that section 3 is involved with each of these. So I'm thinking it's probably going to be section 3. So we're going to go ahead and choose a test point from section 3. And I would choose one that's on one of the axes. Try to do the y-axis if you can, because you'll see it makes things a little bit easier. So maybe I'll choose like this point right here, which is 0, -5. And I choose that because plugging a 0 in for x tends to be easier when we're in slope-intercept form. See, because that would give me a -5 is less than or equal to 3, which is a true statement. And then here it would give me the -5 is less than or equal to -4, which is also a true statement. So therefore, I know that this thing is correct, so I'm going to shade that section. Okay? So I get my crayons back out, and I'm coloring. Coloring with my crayons. I'm really good at coloring. And there it is. Okay? Same thing with the next one. We can tell right away that these are going to be parallel lines, so my fourth option is going to be no solution, but I can't come up with that until, I can't decide that it's no solution until everything else has failed. So the first one's got a y-intercept of -1 and a slope of 3. And there's no equal to condition, so I'm going to use a dotted line this time. And then a y-intercept of 3 and a slope of 3. And once again, there's no equal to condition, so I'm going to use a dotted line. We can see these two are pretty close together, so we're going to have to be very careful, especially in choosing our points here. But when we look at something like this, again, I've got option 1, option 2, option 3, and then option 4 would be if it happens to be no solution. Okay? So for this one, I look at this thing again, and I say, all right, this first line, which is the one that was, it would be this line, I want to be greater than that line, so that narrows it down to these two sections, because they're both greater than that line. And then the second line I want to be less than, so that's this line I want to be less than, that narrows down to these two sections. So again, we can see the section that they have in common that each of them would utilize is section 2, is that middle section. So I'm going to choose a point from section 2, and it looks like 0, 0 is available, so I'm going to plug 0, 0 in. When I plug 0, 0 into this first one, I get 0 is greater than a negative 1, which is a true statement. When I plug 0, 0 into the second one, I get 0 is less than a positive 3, which is also a true statement. So now I know I'm going to be shading in between there. Okay, so I'm going to go with, let's see, red. I haven't used any red yet. Yes, I'll shade that one red. Ooh, I got a little crazy, got a little outside my lines. You know, I got really excited about coloring. And there it is. Okay. For this one might be a little bit trickier, especially in terms of narrowing this thing down, because as I look at this thing, like this first one, I would probably graph using the x and y intercepts, so I would blot this out and find out that the y-intercept is 3, and then I would blot out the other piece of this thing, plug a 0 in for y, and find out that the x-intercept is also 3. So that gives me my x and y intercept. I would probably do the same thing with the next equation, or the next inequality. I'd plug a 0 in for y and for x, and find out that the y-intercept is going to be a negative 3. And then, of course, I would reverse that and plug a 0 in for y, and find out that the x-intercept would be a positive 2. And then I'm just going to graph each of these using the intercepts. So that first one had a y-intercept of 3 and an x-intercept of 3. And what's nice about that is now I can kind of see the slope here. It's up 1 over 1 to get the rest of these points. There was no equal to condition for that one, so I'm going to draw a dotted line. And then the second piece had a y-intercept of negative 3 and an x-intercept of positive 2. And again, I can kind of see the slope. It's up 3 over 2, up 3 over 2. The other option would be to solve each of these for y so that you can have it in slope-intercept form. There's an equal to condition on that one, so I'm going to use a solid line. And now from here, I just have to determine which section I'm going to shade. And really, this one looks a little bit more like a toss-up than the rest of these were. So what we can do, if we're not sure, we'll take a guess. And I'm going to start with section 1 because it's got the order pair 0, 0 in it. And watch what happens here when we plug 0, 0 in. When I look at this first line, which is the dotted line, I plug in 0, 0. I get 0 is greater than 3, which is obviously not a true statement. But think about how that helps us narrow this thing down. If I only had the first equation graphed at the first inequality, if I got rid of this other guy, if I get a false statement here from 0, 0, it means that I'm going to be shading this side of the graph, which means that by plugging that in and getting a false statement, it narrows it down to these two sections. Okay, and then I can do the same thing with the other value. If I plug 0, 0 and I get 0 is less than or equal to a negative 6, which once again is a false statement. So again, if I think about if I only had the solid line and I got a false statement out of 0, 0, it means that I'm going to shade the other side of the line, which would narrow it down to these two pieces. So now I can kind of see that I think it's going to be section 3. Looks like that's where my overlap is. And so I'm going to kind of hit the reset button on all of this, and I'm going to choose a point from section 3 to see if it works. And I'm going to choose this point right here, 4, 0, and I'm going to plug it in and make sure. So I plug in 4, 0. I get 4 is greater than 3, which is a true statement. And then here I plug in 4, 0, which is going to give me a negative 12 is less than or equal to negative 6, which is also a true statement. So once again, I've found the section that I need to shade, and I'm just going to go ahead and shade that in with my crayons. And that's it. Okay, so again, when we're doing this, we're graphing the linear components. It breaks our graph up into pieces, and we just have to determine which piece we're going to shade, and we do that using a test point. Okay?